Today I've taken topic introduction to limits. As we know, the limits is the core topic of calculus. I've explained already about the limits. Limits is used in many limit is used in many fields. When we'll find out the heat derivative, limit is used. When we'll find out the continuity, even the limit is used. You can see the limit and derivative. These all are the problems of the hill limit. So let's see. Before doing limit problems, we have to know the function or value function in determinate form. Then we will learn meaning of x tends to a. After that we will see limit of function. Firstly, function. Here we go, definition of the function. Let a and b be two non-empty sets, then relation, the function is also a relation, but this is a special type of relation. The relation from set a to set b is called function if every element of a corresponds with the unique element of B. Here I have underlined, okay, into in some words, every element, unique element of set B. Every element, if these words are not satisfied by any relation, then relation is not called function. That's why these words should be satisfied. I will show I have shown also in diagrams. By mapping diagrams I have made clear why we need, okay, these words to be satisfied. The function from set a to set b is denoted by f such that a to b. So I have made clear with arrow diagram, or you can say the mapping diagram. Arrow diagram or a mapping diagram, one and the same thing. Here you can see in video arrow diagram or a mapping diagram, or each and every part of the function here. This diagram is very important to understand each and every part of your function. Function in left hand side, okay, left hand side of mine, I have drawn one circle, one circular diagram, and on the right hand side also I have drawn, okay, another one circular diagram. Left hand side circular diagram represents set A, and on the right hand side circular diagram represents set B. Set B. Inside of the circular diagram, or left hand side circular diagram, I have written x, and on the other side I have written y is equal to f of x. So x is the element of a, y is equal to f of x is the element of b. When they form a function, or when they make a relation, or special type of relation which is also called a function, then x is called, okay, pre-image of y, or y is equal to f of x is called the image of x, image of x under function, image of x, or you can see the value of a function. This is the value of function. I was given one example. You can see here, if y is equal to f of x is equal to 2x plus 3, then at x is equal to 1, y is equal to f of 1 is equal to 2 into 1 plus 3, that's gonna be 5. Okay, now 5 is called the value of function. Y is equal to f of x is equal to 2x plus 3 when x is equal to 1. We can say the 5 is the value of function at x is equal to 1. That's the value of a function. And let's see more thing in a function. Set a is called domain, and set b is called the codomain. So what is the range of the function? So here I have shown inside the circular diagram b, one bonded curve I have made. Inside the bonded curve we have a y is equal to f of x, that is called range. In bracket I have written set of the images of elements of set A. So what is the range? Okay, sometimes, okay, your B may be the range, okay, sometimes your set B may not be the range. Okay, so don't say the B is the range of the function. So what is the range of the function? Set of the images of elements of A in set B. That's your range of the function. Okay, everybody. Mm, all right. Now I have here written. I have drawn okay some diagrams on the board. So whether they are function or not, okay, to make it definition clear, see, let's see by these examples. In first arrow diagram you can see A to E, B to relation, A to E, B to F, C to F, D to I, H and I, just without any relation of elements of A, they are there. Now here function from A to B, yes, this is the function from A to B. Why this is called okay function from A to B? Because this is gonna satisfy the definition of function. See, according to the definition of function, if we recall the definition of function, every element of set A, all right, every element of set A corresponds, okay, every element A is corresponding, B is corresponding, C is corresponding, D is corresponding, and another word, okay, be the unique element of set B. Yes, unique means only one element is corresponding with A, means okay, only one element. B is corresponding with F, only one element. C is also corresponding with only one element, okay, F. Although both have a same images, but both are corresponding with only one element. D is okay corresponding with only one element. So this is completely satisfying the definition. So this arrow diagram or this mapping diagram represents a function from set A to set B. Let's see the another diagram. I have taken okay second diagram. In second diagram, 1 is corresponding with 1 and 2 is corresponding with 4, 3 is corresponding with 9, but 4 is not corresponding with any element of set B. Can we say the function according to the definition? No, because this is not going to fulfill the definition of the function. If you see one is okay, one is corresponding with 1, all right, 2 is corresponding with only 1, all right, 3 is corresponding with only one element, all right, okay, but 4 is not corresponding with any one element. What is the meaning of this one? In another sense, you can say this arrow diagram is not satisfying the every element of A. This is not fulfilling this statement. Every element of A corresponds with, here is 4 is not corresponding with, so every word is not satisfied okay by this diagram. So that's why this is not a function, and that's why I have crossed okay function from set A to set B. No, this is not function from set A to set B. And then and third arrow diagram I have taken here. In third arrow diagram you can see 1 is corresponding with A and 2 is related with B and 2 is related with C, 3 is okay corresponding with D, 4 is corresponding with E. So if we see okay this diagram, then you can say yeah, every element is corresponding, yeah, fulfilling okay, this is okay, this is satisfying the word okay every element, because every element of A is corresponding, 1 is, 2 is, 3 is, 4 is. But second statement, if we recall the definition, we find out okay with unique element of set B, is it satisfying this word? So no, because 1 is okay only 1, all right, 2 is not satisfying this word, unique word, because here 2 is corresponding with two elements of B. That is okay, 2 is corresponding with B, also 2 is corresponding with C. This is violating this definition of function, because we need okay every element of set B corresponding with unique element. So this is not satisfying the unique word, so unique word, all right. So that's why this is not function. 3 is okay only 1, 4 is only 1, but 2 is not okay corresponding with unique elements, means only one element. That's why this is not function from A to B. All right everybody, I think now clear about the function. Now we will know about the value of function. Uh, Already I have explained what is called the value of a function. When I define function, here you can see y is equal to f of x. At x is equal to a, y is equal to f of a is called the value of function. There are two types of values of function I have taken here, finite and infinite. If we have a finite, okay, you can say f of x exists, or you can say function is defined at x is equal to a. If we have a finite value, if we get the finite value, and if you see, okay, infinite mean not finite, then you can say f of x does not exist, or you can say the function is not defined at x is equal to a. For examples, by looking these examples, everything will be clear. For example, I've taken, if we have y is equal to f of x is equal to 2x plus 5, at x is equal to 2, y is equal to f of 2. It's going to be 9. 9 is a finite value. Okay, well, you know, I think finite and infinite numbers. So this is a finite number. 9 is finite value. So if this is a finite, then we can say, according to the definition and defined and not defined concept, f of x is defined at x is equal to 2 because of finite. Okay, again you can see here this okay, table, y is equal to f of a, finite, and then exist or defined at x is equal to a. If it is infinite, then the function does not exist or is not defined at x is equal to a. So okay, now second example I have taken, if y is equal to f of x is equal to 1 upon x minus 2, this type function you might have, at x is equal to 2, y is equal to f of 2 is equal to 1 upon 2 minus 2, you got to be 1 upon 0. If we have a 1 upon 0, we write down the infinity. Infinity is not a finite number. Okay, actually infinity is not a number. This is just your notation. This shows your value is not finite. All right, this shows your value is not finite number. So later I'll explain about infinity, why we write infinity sign when any real number which is not equal to 0 is defined by 0. All right, later we will see. So I think now clear, okay, in which case function is defined and in which case function is not defined. Okay, so now let's see the another form is indeterminate form. This is also related with the value of function, and here I have taken again y is equal to f of x. Let's suppose, okay, another one example function. Let's I have taken, okay, function y is equal to f of x, x square minus 4 upon x minus 2. At x is equal to 2, y is equal to f of 2, 2 square minus 4 upon 2 minus 2, 4 minus 4 upon 2 minus 2, which is gonna come 0 upon 0. So you know 0 upon 0, 0 divided by 0 does not give any real number. 0 divided by 0, this is also called the meaningless form. 0 divided by 0. Some students, what they do, I found, when we have to find out the value of a function at x is equal to 2, they try to factorize. So let me clear it. Y is equal to f of x is equal to, they try to write x minus 2 into x plus 2 divided by x minus 2, and then they cancel out x minus 2. This is wrong. Okay, it works if x is not equal to 2. When x is equal to 2, it doesn't work. Okay, you are not permitted to cancel 0 upon 0. All right, so that's why at x is equal to 2, here we have 0 upon 0, which is a meaningless form, and this form is called in mathematics indeterminate form. This is called, okay, indeterminate form. So now I think you are clear. So what is the indeterminate form? If you get the meaningless form, that is called your indeterminate form. If your function can take the form 0 upon 0, then you can say indeterminate form. We have other forms of indeterminate, so I've written here other indeterminate forms. infinity upon infinity. Sometimes your function can take when we use okay infinity. Later you will see, definitely you're gonna see infinity upon infinity, infinity minus infinity, 0 raised to power infinity. These all are indeterminate forms because they don't have any meaningful. These all are okay meaningless form, and they don't give you any definite real number. That's why we say these are indeterminate forms. Okay everybody, I think now clear about the indeterminate form. Okay, so again I'm going to show you here introduction to limit function. We have defined today function, then value function and indeterminate form. So once again you can see this side, in which case we can say the function is defined and value function is undefined, and I have explained with examples. You're gonna see here. You can pause the video if you want to see carefully. And infinity, and with infinity I have written here, I have drawn one arrow. So arrow I have shown. Later it will be explained why we write infinity when any real number is divided by 0. Any real number means okay not equal to 0. All right, thereafter I have explained here indeterminate form. What is the indeterminate form? I think now you all are clear about the indeterminate form. Okay, so that's all for today. In next video I'll tell you, I'll teach about the meaning of x tends to a, and then we're gonna find limit of function. Okay, till then, bye bye.